we're gonna do an experimental video number 3 all about NOR gate circuit. So, ano pa bang hinihintay natin? Let's go! First, we have the objectives for this experimental video. The first one is to examine the characteristics and operation of a TTL NOR gate. The second one is to implement the NOR functions using combinations of OR and NOT gates. And here are the list of the equipment and materials that we're gonna need. 5 volts DC power supply, 1 piece of 74LS02 quad 2 input NOR gate, 1 piece of 74LS04 hex inverter gate, 1 piece of 74LS32 quad 2 input OR gate, 1 piece of 5mm red LED, 1 piece of 1/2 watt 220 ohms resistor, 2 pieces of SPDT switches, and 1 piece of breadboard and some jumper wires. Here we have some introductory information about NOR gate. The NOR gate has an output that is normally at logic level 1 and only goes low to logic level 0 when any of its inputs are at logic level 1. The logic NOR gate is a combination of a digital logic OR gate and NOT gate connected together in series. Here we have at figure number 1 a logic symbol for a 2-input NOR gate, and in figure 2 the combination of logic gates required to implement NOR gate function. Now let us start our procedure. The first one is to construct on the breadboard the NOR gate circuit shown in figure A. Set the NOR circuit to each input combination as shown in two tables. Observe and record in the two table the output for each combination. Then, using the same circuit as shown in figure A, complete the other truth tables. Here we have in figure A a NOR gate circuit. We have two SPDT switches, pin number 2 and pin number 3 as our input, pin number 1 as our output, pin number 14 as our VCC, and pin number 7 as our ground. Here we have our first circuit. We have two SPDT switches, a red LED 5mm, 220 ohms resistor 1/2 watt, 74LS02 IC. We have here the negative polarities and the positive polarities. The pin number 1 as our output, pin number 2 and 3 as our input, and pin number 7 as our ground, and pin number 14 as our VCC. Now, let's test our first circuit. Let's turn the power supply on for the 5 volts VCC. Here we have our circuit. Since NOR gate is the opposite of OR gate, the LED will only turn on if both of the switches are in low input. And the LED will turn off if any of the switch or both of the switch are in high input. Here are the other truth tables with open input. Our next procedure is construct on the breadboard the NOT OR gate circuit shown in figure B. The next one is set the NOR circuit to each input combinations as shown in truth table. Observe and record in the truth table the output for each combinations. Here we have in figure B a NOT OR gate circuit. We have two SPDT switches, an OR gate which is pin number 1 and pin number 2 as our input, pin number 3 as our output, pin number 7 as our ground, and pin number 14 as our VCC. And in NOT gate, we have pin number 1 as our input, pin number 14 as our VCC, and pin number 7 as our ground, and pin number 2 as our output. Here we have our circuit number 2, the combination of NOT gate and OR gate to produce a NOR gate circuit. We have the two SPDT switches, red LED, the 220 ohms resistor 1/2 watt, and our two ICs. The first IC is the 74LS32, which is the OR gate, and the second IC is our 74LS04 as our inverter. And we have here the negative polarities and the positive polarities. Now, let us test our second circuit, which is the combination of NOT gate and OR gate circuit to produce a NOR gate circuit. Let's turn on our power supply on for the 5 volts VCC. Here we have two switches as our two inputs. Just like a NOR gate, the LED will only turn on if both of the switch are in low input. But if any of the switch or both of the switch are in high input, the LED will turn off. The output for NOR gate circuit is the invert output of OR gate using NOT gate. That's it for our experimental video, guys. We were able to achieve our two objectives, which is to examine the characteristics and operation of a TTL NOR gate. And the second one is to implement the NOR function using the combination of NOT gate and OR gate circuit. Again, guys, I'm Mariza Ignamara, and I hope that you learned something from this video. And thank you for watching, guys. See you again!